confession to start with that I'm an ecologist, not a landscape contractor or practitioner or a landscape architect. And my starting point has always been an interest in the rarest, most special habitats that we've deigned to leave behind on the planet at the moment, and helping and supporting them by expanding them, buffering them, and so on and so forth. But over the last 20 years, I've sort of made a personal odyssey towards urbanism because of the impact of urbanism on the natural world, which I started out thinking could only be negative, but as we've heard this morning, can be reversed and indeed synergistic. And that's very much a change that's led me to all kinds of strange places, like lecturing for the last 15 years at the Bath School of Architecture, where I'm a research fellow at the School of Architecture, not the usual trade for an ecologist. So that's a little bit about the strangeness that is me. The other thing is that the issue that's come up a lot today is about balance. You hear wonderful ideas and solutions for, I don't know, creating wonderful carbon sequestration in grassland, all very exciting stuff. And all these innovations are wonderful. And the question is, how can we get the optimization, as Cheda Maksimovic was talking about, how do you optimize these systems? It's almost becoming too bewildering to get our heads around. And amongst all of that, the biodiversity which we share the planet with, and 50%, now 80% in the UK living in urban areas. How do we deal with the preservation of species? Do urban areas have a major role in conservation of species? There are some people still in natural England, for example, who don't believe that's to be the case. And urban conservationists like Pete Massini have for years felt strongly about the nature value of cities in true tooth and claw rarity value, but a lot of people are ignorant of that. So to somehow tie all these together with this new interest in green infrastructure and these new technologies is really what this talk is about. And so I'm not going to linger on any of this. We know that green infrastructure in general can have systemic effects at the city scale. Heat island reduction, 2003 it was, when 25,000 people died in Europe from heat stroke, and quite a lot of people, over 800 in London did. And these events are going to become 1 in 5, 1 in 10-year events by the time I'm retiring. The idea that street trees can prevent crime, the work of Kuo in Illinois. This is general green stuff doing good things. And this is 25, 30 years of academic research. This isn't just somebody thinking, oh, it might be nice to have a green area, it might make you feel better. This is research on actual pathological behaviors of human beings being reversed by the green stuff. But biodiversity isn't just the green stuff. It's the green stuff in all its diverse forms. It's not just species diversity, it's variety diversity within species. We've been hearing about cultivars of grasses that are fundamentally different in how they behave underground, which provides very, very different functions. And processes. Biodiversity isn't just about the things you see and touch. It's about the processes in the soil, in the air, in the interaction between the biosphere and the elements of the biosphere and the chemical soil and the atmosphere. And biodiversity is about the everythingness of everything. And it's often forgotten when you're dealing with projects and you think it's flora, fauna, birds and bees. We've got recently, when there was the bonfire of the regulations and the statutory guidance that people are taking years to write, like PPS 9, were thrown away, this voluntary sector stepped in and said, look, no, this is really important stuff, guys. And this was endorsed by Parliament. I was there when they did it, and they said this will be a material consideration in planning, even though this is voluntary sector guidance. I'd recommend that to you, because a lot of what's been said today is encapsulated in there in summary, in brief summary. And it does talk about multifunctional green infrastructure, not getting one-track minded about what green infrastructure does, or indeed blue infrastructure, but trying to make all of it be relevant. But, I mean, very simple things need to be said, because sometimes in projects you find they're not reflected. The more diverse your infrastructure is, the more ecosystem services you're going to get. And so that when we start projects as a biodiversity company, my company, Biodiversity by Design, we're immediately thinking of all these things and work we do in Southeast Asia on sea defenses and mangroves and whatever else. The last thing we're worrying about necessarily might be pollination, although it might be, as working with the National Pollinator Strategy recently, the first thing. But ideally on every project you're doing an audit of all this stuff, whether it's a little patch of ground in Wootton Bassett or an entire mangrove swamp in Malaysia, it's the same stuff. And it's thinking about all of that and the social good that it does people. And one thing I fundamentally believe in now is that you can't take out the human factor from biodiversity. There isn't biodiversity in the environment and then people. I mean, Carl Jenks wrote a wonderful book called Ecosystem Functioning, saying that the reason we get all this wrong is that the idea of an optimally functioning ecosystem is somehow some scientific abstraction. It's not, because there isn't an ecosystem on Earth that isn't fundamentally affected by human beings, and for which human beings fundamentally relate. Even the Amazon jungle, we now discover, used to be, heavily urbanized in a sense. But this is an ecosystem of types that does lots of functionalities that we've talked about today. Briefly, in the approach to urbanism that I'm trying to help develop is this idea of how many more things can you get? How much harder working can you make that urban infrastructure, as Pete Massini was saying? This is the Athletes' Village, less vaunted in the press than the wonderful Olympic Park, but quite large nonetheless and having lots of components to it. And just to point out a few of these, the thinking that went into trying to make each bit of the green infrastructure functional in a sense. Living roofs, we've heard a lot about living roofs, but on here we try to have 4 or 5 different typologies. So the actual diversity of having a roof versus a ground landscape, the roofs themselves we're trying to diversify into at least 4 types of what I call analogues of native habitats. And I'll come on to why we did this, but the functionalities that you get from that will obviously be greater because you can have different species using the different roof typologies. And that's in early days. A Central Park, which had water in it, very fundamental part of something that I'll talk about in a minute on biophilic design, and woodlands which already had wild ground flora sowed at the time of sowing. New techniques that were developed for that, lawns which flower, talking about how you could have carbon sequestering lawns, but what about a lawn with 25 native species in that require regular mowing to survive? And things like this, in order to try and maximize opportunities, rather than saying, oh no, actually this area is just about kicking a ball, so we can't have that. Yes, you can have both, quite often, if you only take the trouble. And finally, a big hole in the ground that was to balance all the water resources coming off the site, and that in the original drawings was just that, a big hole in the ground, which was probably going to have a certain size and space, but transformed into a wetland with about 5 or 6 major habitat types, and then within those habitat types, all native species and marshlands with 35 native species of plant and so on. So all about optimization, maximization for various reasons. And at that point, we did start looking at these different habitats and do a very simple back of a matchbox ecosystem service analysis that each one of those landscapes is going to do something. Even a green roof is a view for somebody. It's having a health benefit as a view. But obviously, something like the wetland, originally thought of just as a place where you balance water, has a phenomenal number of quite fundamental high-performing ecosystem services because it's just got more stuff. So the next point is, the more biodiversity a green infrastructure can be, you're going to get more species of conservation concern. And that obviously works within habitats, not across habitat typologies. But a great example of this is the guidance of bug life produced on living roofs, which show that you, by just changing the detail at which you're thinking in quite simple ways, you provide for a vastly greater variety of species, including very rare things. And I got very interested in this up to 10, 15 years ago with Gary Grant and others we wrote books with, about how much rare stuff there is in cities if you design habitats correctly for them. His cities don't have the disadvantage of being sprayed to death with pesticides and herbicides like a lot of the countryside. In fact, they're quite clean places by comparison to a lot of the countryside in that one regard. And you get rarities. Here's some statistics you can look at. Switzerland in that particular example. Rare stuff, red data book species, and in the UK, national rarities found on roofs. Not in just ones and twos, but quite a lot of species somehow finding their way through the aerial plankton to these sites. And they're sort of aerial zoos, aerial nature reserves, which have many of the characteristics of ground-level landscapes. Others in the ecology world have said they're not fully functional ecosystems. But I think I'm much more with land life on this, that the blur between the boundary between urban and rural is far, far less distinct and theoretical. Well, here's an example of a roof in Switzerland, which was designed as mitigation for loss of very important grassland near rivers, riverside grasslands, with nearly all, apart from the river flowing over the roof, which it doesn't have, nearly all the characteristics of that, including ponding of water, many variations in topography, bareness of soil, tallness of soil, and the functionalities of that roof, not only for invertebrates, for many other things I'll come on to, is huge. Here's another roof in Switzerland with over 150 species of native plant that an average botanist wouldn't be able to tell as different from a native meadow. In fact, it's the only place in Switzerland where this meadow is now left, is on a roof, and it's now a national park. And this is a Swiss hospital with a view from a roof where I found this amazing sward of orchids growing in the very, very narrow, thin soil skim due to its low nutrient status. And again, in the design of space, if we think for the rarities can occur if we design the green infrastructure not only to be green infrastructure, but to be varied in form and shape and size, canopy trees, other things, because the actual species that vary often require particular niches within that. So it's not just about having street trees, it's about having certain combinations of street trees and shrubs to create form and shape and microclimates that rarer species may use. So another typical thing that's said all the time, monoculture is susceptible to disease. And there's papers and papers on this in all different types of applications from agriculture onwards. And generally speaking, greater diversity within green infrastructure, including in urban areas, will reduce that risk and increase resilience. This sort of thing is not, and this isn't some semi-agricultural, semi-industrial application of willow cultivation. When they do short rotation coppice, which is basically an industrial process, you've got lots of different types of cultivars all grown into mixing in order to reduce the hazard and effectiveness of particular disease species coming through and sweeping through it like a dose of salts. Street trees planted as monocultures and lines, much more susceptible. We've seen examples of that with things like horse chestnuts and so forth in London. And yet this obsession with landscape legibility of single species plantings is often quite dangerous, especially in a changing climate. And of course, in designing for a low pest environment, we need to design for all the things that provide so-called free ecosystem services, free as much as we provide for them in the first place, that is. All those species on there, from sawfly larvae to sand martins, can provide quite significant effects on pests and vectors, which are going to become all the more important as we have climate change. What's going to happen when all our suds become breeding areas for mosquitoes and malaria? We are going to have this balance, and yet you can have sud systems in Singapore where they have malaria and nastier diseases. So it's about learning perhaps from the tropics and places like this about building in that diversity which provides the natural control of the pathologies. One way we did this in the Olympic Park, there are people here who took part in all of that, not the Olympic Park, the Athletes' Village, is to build in death. Most ecosystems have cycles of life and death, and when you produce a new landscape, the problem is you haven't got the old stuff. So here we've got examples of planted dead trees. Why would you do such a crazy thing? Well, they look quite fun, but also they're providing for deadwood insects, many of which at one stage or other in their life cycle are predators of pests. So it's a natural biological control system. It does work. Very rapidly. They look quite amazing and provide all other sorts of niches, and they can be lying down or standing up or a combination of the both. And then the other thing that's really interesting me more and more is in a given ecosystem, if your ecosystem is more biodiverse within its range of limits, like a heathland's quite a limited species diversity, but the more diverse that is, can it provide better ecosystem services for other things? Now, for example, pollination's an obvious one. If you have all your flowers of one type, you're only going to help, sorry, it's a lousy photograph, but at one particular type of pollinator. By providing a whole variety of forms of flowers, the other pollinators come in. Now, obviously, the more, if you look at ecosystem integrity scientifically in the papers, at the ecosystem level, the shocks that ecosystems get can be resisted relatively well. And it's very hard to see perturbations because something else steps into the place when a species is lost quite often. At the community or assemblage level, you see the shocks much more. You lose a species and it can collapse. And I think that simple things like thinking very hard in landscape schemes about the morphology of flowers, their flowering times, it's often done in good landscape practice. This is thought about, but it takes time and money and effort to do. But it does need to be thought about in order to ensure that diversity of pollinators so that anyone that's having a bad day at the office can be replaced by another. Here's an example of a living wall where, again, designed by Gary Grant, who very much favors a native species or naturalized species approach. And because they've been here much longer, they tend to be more resistant. And also because of that ability to support very much more diversity of pollinators to increase the resilience of the other ecosystem services that piece of green infrastructure is providing. Water purification is an example. I got very, very impressed by one paper I read. Often it's just one paper you read that sets you off on something. And this was in Slimbridge, where they had to treat all the effluent from their wildfowl cages. And they thought, well, we could have a reed bed, but what about other systems? Maybe they'd be just as good for treatment, or possibly even better, and have more biodiversity value. And the papers there, I won't go into the details, but in fact that's what they found. By having a greater variety of wetland typologies and plants, they produced a better quality of water treatment and a much higher biodiversity value. Not that reed beds aren't incredibly valuable, of course they are, but we're talking about diversity and sometimes supporting uncommon species. And this is the Athletes' Village again, where exactly the same principles as that Slimbridge system were writ large in order to provide a whole sequence of different types of wetlands to build in a resilience to functionality that would work with different years, different weather conditions, climate change, and so on and so forth, not just tomorrow, but in 20, 30, 40, 50, 60 years' time. So you start out with settlement ponds, which do a lot of the treatment at one time of year, but then you go through labyrinths of water, which do a different sort of treatment, have different typologies in there. Woody plants take out more phosphorus, for example. And then you finally end up in a biodiverse marsh, which isn't a reed bed, but nonetheless it's got 35 species of native plants and planted in a careful sequence so that they can all provide different niches for treatment of water and provision of a wider range of biodiversity. Interestingly, it doesn't just apply to things like water treatment, which a lot of you people are familiar with. This amazing research at Exeter has shown that cows fed on better meadows produce tastier milk, which can produce tastier, high-quality cheeses. It's been shown in France for things like bries and various types of cheese, which have been done in tasting experiments, a bit like masters of wine. There are such things as master of cheese, which I'd love to be one day. But seriously, we have an obese nation. It is much to do with food is about quality over quantity. And by producing less of something, but at a higher and changed quality, because of all the various things that go on with the gut flora, which I'll come on to in a minute, you're getting changes in the chemistry of the product which have beneficial effects in terms of a market share because you're producing a high-quality product rather than a mass-produced product. A similar thing is, orchards. Old orchards are now endangered species of habitats, but they weren't just a bunch of trees with apples on. They had, unlike many modern commercial orchards, they had a variety of other things going on, including beehives, nectar sources for bees, and that as a system for producing fruit sustainably and tastier fruit, and perhaps fruit with higher nutritional value, is something with lots of complexities and scientific interest that we're just ignoring and actually losing at a rate of knots still, unfortunately, in the UK. Even allotments, is an allotment a place where people go and get exercise and health and grow plants to eat, or is it a combination of things where things like biophilic benefits, which are now much vaunted in the scientific literature, can be done? Can you get more out of an allotment space, which, frankly, a lot of people in parts of the country think unsightly? Need they be? They needn't. This is a marvelous example from a landscape architect from my previous company. I worked with Nicholas Pearson Associates, who knows how to do a bit more than just grow the veg. Cooling. Now, very interesting. We know about cooling and roofs and ribbing walls, but this interesting paper caught my eye about how just changing the morphological mixture of plants on a roof changes the functionality of the green roof in terms of its ability to cool or indeed absorb and treat water. So that requires the conservationists to come back and look at it the other way. And these are examples of how that morphological difference can work with physical structures. And then the health benefits we've heard about, and you know about this, but this one paper shows that the biodiversity increasing in a particular habitat leads to greater health benefits that were talked about by land life. And that with each one of these indices, not only can untrained people appreciate nature better, but they get greater benefits out of it. And that's in Medical Research Journal. That's the sort of product designing with that in mind that you produce. That's a hospital in Switzerland. And that is a park that's designed for people with those sorts of benefits required, or a university campus in Nottingham with those sorts of interests behind the driver for doing it. And just one interesting thing that I might leave you with, just the level of detail with all of this, is that we are now walking around with 10 times as many bacteria as we have body cells. They're small, so that they don't take up all our volume up, but the point is that they are on our skin and everywhere else. And this paper produced showed how people living in areas deprived of certain mixtures of aerial biota of pollen and organic fragments tend to be much more susceptible to infections and inflammations than people living in more rural areas. And the interesting thing is that the bacteria communicate with the body via these various chemical methods. And by cleaning them off or not having them there, you're actually ending up in an impoverished biotic environment yourself. We're not walking around in isolation. What I think is that if all this matters at all, then we have to look at it at a more sophisticated level. We need to set targets for the biodiversity in the green infrastructure rather than just let it all happen and see what happens for the best. Look at our system, define our areas, and tabulate, and this is my last slide, tabulate the things we're expecting to get, why we want them, and where they're going to turn up. And I can tell you, if you do this, you can get incredibly accurate at it. When we did Greenwich Peninsula, we were 85% accurate with our predictions for a 3-hectare wetland. And that means that it's taking the sort of level of prediction and science that you would do with engineering a bridge or building a piece of architecture. And if it's going to be taken this seriously, I think that would help with the National Ecosystem Assessment and the quantification that's going on of ecosystem service in economic terms to take it to the next level. Thanks very much.